Hi everybody. 7.2 day 3. It looks like this with cosine 15. Example 4. Use a calculator to approximate the value of a trig functions. Today's 3/24/20. I don't know if you have a graphing calculator or not. I won't hold you responsible for it until we get back to class, if we do get back to class. But on a graphing calculator, there's a button right here called mode. Right here, mode. And when you hit the mode, then it gives you some choices. On the third row, it's radians or degrees. So if we keep it on degrees, then you have to hit second, and then see how it says quit, to get out of that. And then it says find cosine 15. Find cosine 15, and it says to 2 decimal places. So you just hit cosine and 15, and since it's in degrees, it'll give you this answer. And what is that to 2 decimal places? Approximately 0.97. 2 decimal places. The next one's definitely in radians because it's pi over 12. So what you do is you go back to the mode button, mode, and you see that radians is on the third row, and you hit enter, so it highlights the radians. Now it's in radians, and you do second quit. Now whatever we do will be in radians, and we want tangent of pi over 2. So my pi button is right here, right above, so I did second pi, divide by 12. What's that to 2 decimal places? 0.27. So if there's no units, it's radians. If it's degrees, and I'm going to write mode right here because that's important that you have it in the right mode. If you do have a graphing calculator, it's good to practice back and forth, switching from mode to radians to degrees. This one is secant. Do you see a secant button on this calculator? I don't. But secant is related to cosine. So we're going to do 1 over cosine 10. And no units equals radians. If there's no units, then there's radians. It's radians. So since it's just a 10, it's not 10 degrees, it's radians. This is still in radians. So it's going to be the reciprocal. Cotangent will be the reciprocal of tangent. Cosecant will be the reciprocal of secant. Because they don't have those buttons on the calculator. So we're going to do 1 divided by cosine of 10. And it's still in radians. Negative 1.19. So if you don't have a graphing calculator, don't worry about it. Your phone might do it. I'm not sure if it switches from degrees into radians or not. You can do it on a scientific calculator. DEG is degrees and RAD is radians, if you could figure out how to switch. So far everything we've looked at has referenced a unit circle. What if the radius is something other than 1? Because so far the radius has always been 1. Although the sine and cosine functions are defined via the unit circle, similar triangles can be used to show that sine and cosine can be on any triangle, on any circle. So they have this right here, and it says consider the following circle where theta is defined in quadrant 2, so we're in quadrant 2. PQ is a point on the circle. X squared plus y squared equals r squared because it looks like this. You have the Pythagorean theorem, x squared plus y squared equals r squared. The angle theta is this whole angle here to get it into the second quadrant. Let P with asterisks x be x asterisk y actually be a point on the unit circle. Notice that the triangles are similar. They both have right angles and they both have this angle, so they have AA, similarity postulate, angle, angle, similarity postulate, two angles the same, angle, angle, similarity postulate. But I'm going to draw the other triangle here. Y star x star 1. Y star over 1 is y over r, right? Y star over 1 is y over r. X star over 1, can't see it. X star over 1 is x over r. X star over 1 is x over r. Y star over x star is y over x. 1 over y star is r over y. 1 over y star is r over y. You can see these properties or these corresponding to the ratios, the corresponding signs are equal. They're proportional. So notice on the left side of each ratio is equal to one of our earlier 6 trig functions. For example, y over 1, y is sine, right? So sine over 1 is y over r. So sine had to do with y, and it still has to do with y, but it's y over r now on a big circle. Instead of just y, it's y over r. So here's an important box. Sine is y over r, and we have to know that x squared plus y squared equals r squared. When it's in standard position on a circle, where the x-axis is the initial side, and P is on the terminal side, this is going to be x over r. Tangent is y over x, where x is not 0. Cosecant is the reciprocal, r over y. Secant is r over x, reciprocal. Cosine, tangent is y, x over y. So what they do is they give you a point, like 3, -4, and they ask you to find each of the trig values, the 6 trig functions. So if you go to 3, -4, what quadrant are you in? You're in the 4th quadrant, and you have to use the Pythagorean theorem to find r. R squared equals 3 squared plus 4 squared, -4 squared. Or you can use the distance formula because you can take the square root. But anyways, 9 plus 16, 25 is r squared. R is 5. The radius is always positive. The radius of the circle is always positive. So it's 5. So if we're going to find sine of theta is y over r. This is x, this is y, this is r. So it's -4 over 5. Cosine theta is x over r, so it's 3/5. Tangent theta is -4/3 because it's y over x. Cosecant, I did secant first. Oh well, cosecant theta equals x over y, which is 3 over -4. It's r over y, so it's 5 over -4. Secant theta is r over x, which is 5 over 3. And cotangent theta is x over y, which is 3 over negative 4. So you're going to be doing those with Pythagorean theorem and finding missing sides. I'm going to type up the homework and post that for you soon. And then you should have one of these in your packet to fill in. I'm going to stop the video and start it again, and we're going to fill in this together. So find this in the packet. You're going to do this for me on Friday, and tomorrow you're going to do the one with just the sines and cosines, where it gives you all the angles, but you're just putting in the sine, comma, cosine. You're going to do that one for me tomorrow. So I'll stop this and I'll start it again in a minute.